9.2 notes, sum and difference identities. This is page 2. And we're going to start by doing the same thing we did on page 1. And we're going to go ahead and find that value of cosine 75 degrees. So, great start. We are going to be able to write this. Let's put it up here. As the cosine of 45 plus 30 degrees. So I've got the sum formula for cosine. This is a cosine sum. So I'm going to rewrite this out. Cosine alpha plus beta. Cosine alpha. Cosine beta minus sine alpha, sine beta. The cosine, so let's write this again with numbers. Cosine 45 plus 30, holy moly. Cosine 45 times the cosine of 30 minus the sine of 45 times the sine of 30. Cosine of 45 is square root of 2 over 2. Again, these are coming right off of the unit circle. This is not helpful if I'm not using values that are on the unit circle. So I could not split this into the cosine of 50 plus 25. That does equal 75, but I don't have exact values for the cosine or sine of 50 or 25 for that matter. Cosine of 30 is square root of 3 over 2. Minus the sine of 45 is square root of 2 over 2. Sine of 30 is 1/2. I get square root of 6 over 4 minus the square root of 2 over 4. We end up with square root of 6 minus square root of 2 all over 4. Notice the similarities to what we found on the first page. You guys are exact values, 30, 45, and 60. We're dealing with 1/2 square root of 3 over 2 and square root of 2 over 2. There's only so many ways we can combine them. So you're going to see a lot of values that look real similar. Okay. So now let's move on to the sine. We've got the sum formula for sine here. Notice there is a pattern in the formulas for sine. It does look different than the formulas for cosine. So here sine alpha plus beta, we get sine alpha cosine beta plus cosine alpha sine beta. So this time we are not using both cosines together, both sines together in a term. We've got the sine of one and the cosine of the other. And here the operation is the same. If I am adding two pieces within the argument for sine, I am adding the two terms in the formula. Same thing for difference formula. Sine alpha minus beta equals the sine of alpha cosine beta minus cosine alpha sine beta. Keep in mind, the order here is going to matter. So alpha minus beta is going to be different than beta minus alpha. We need to make sure that our sine alpha, this first one, matches our leading term here. Okay, and so here's the general form of that formula. We don't want to write out two separate pieces. Notice that top operation matches the top operation here. So the sine of alpha plus or minus beta is going to equal the sine of alpha cosine beta plus or minus the cosine alpha sine beta. So we get everything in there. So let's do this. I got the sine of pi over 3 minus pi over 4. So I've got a difference, sine of alpha minus beta. And again, I'm going to write this out. Sine alpha cosine beta minus, these match, cosine alpha sine beta. Keep in mind, there's one sine alpha, there's one sine beta, there's one cosine alpha, there's one cosine beta. Nothing should be duplicated. Okay, So now I'm going to fill in my angles here. I got sine of pi over 3 minus pi over 4. That's going to be the sine of pi over 3 times the cosine of pi over 4 minus the cosine of pi over 3 times the sine of pi over 4. The sine of pi over 3 is square root of 3 over 2. Cosine of pi over 4, we're going to start to really like these cosines and sines of pi over 4 just because they're exactly the same all the time. Cosine of pi over 3 is 1/2. Sine of pi over 4, square root of 2 over 2. I get square root of 6 over 4 minus the square root of 2 over 4. Have a common denominator, so we're going to combine those into one fraction. And we get square root of 6 minus square root of 2 all over 4. Okay, notice something, we'll talk about that in a minute. Let's go on to B. Another subtraction. So sine of 135 minus 120, this is laid out for you. I mean, what we're finding here is the sine of 15, right? 135 minus 120. Notice also over in A, pi over 3 is the same as 60. Pi over 4 is 45. A was also finding the sine of 15 degrees, so we really should be getting the same value here. And you'll find when you're using sum and difference formulas, there's usually multiple ways to get out what you're trying to find. Okay, so this is a difference again. Sine alpha minus beta. So sine alpha, cosine beta, minus cosine alpha, sine beta. Sine of 135 minus 120, you'll notice in the notes, I go back and forth between angles in radians and angles in degrees. The text does that. For those of you moving on to calculus, you will not use degrees in calculus when you are talking about trig functions. Rotation, yes. Trig functions, no. So make sure you are very familiar with those radian measurements. So I got what here? Sine 135, cosine of 120, minus the cosine of 135, times the sine of 120. All these should have degrees, 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 degrees. Equals the sine of 135, that's in the second quadrant. Sine is positive, square root of 2 over 2. Cosine of 120, cosine is negative in quadrant 2, so negative 1/2. Minus the cosine of 135, that's going to be negative square root of 2 over 2 because the cosine is negative in the second quadrant. Sine of 120 is going to be positive square root of 3 over 2. And I'm going to multiply this out. Negative square root of 2 over 4 minus, I'm going to get a negative, so I'm going to make that a plus, square root of 6 over 2, and I get square root of 6 minus square root of 2 all over 2. Okay, exact same thing that we got in part A. Notice it's also the exact same thing that we got above in part B, because cosine and sine are cofunctions, and 15 degrees and 75 degrees are complementary angles. So down here are cofunctions. The sine of 15 degrees, which is what we found on the bottom part here, equals the cosine of 75 degrees, which is what we found on the top part. And that's working how it's supposed to be working.